When open-weight models like Gemma 4 outperform models 20 times their size, the divide between paid cloud APIs and local hardware effectively disappears. Instead of sending your prompts across the internet to servers thousands of miles away, you can download the model weights once and run the entire cognitive process directly on your own hardware. The two leading models currently driving these local agentic workflows are Gemma 4 and Qwen 3.6 Plus. Standard benchmarks for reasoning and math show both models performing at a production-grade level, which makes the hunt for the smarter model a secondary concern. The focus shifts to the architectural trade-offs between your specific need for low-latency execution and your requirement for deep multi-step planning. If you pick a model based purely on benchmark hype, you'll face latency bottlenecks, hallucinated tool calls, or illegal word blocks long before reaching production. For enterprise deployment, the immediate hurdle isn't technical at all, it's the legal and procurement review. This diagram breaks down Gemma 4's Apache 2.0 license. It grants broad rights for commercial use and modification, and specifically includes explicit patent protection for downstream developers. These permissive terms effectively eliminate vendor lock-in risks, meaning procurement teams can approve deployments without ongoing negotiations. Now, looking at the custom HUMOM license used by Qwen 3.6 Plus, we see a specific commercial limit triggered if your service exceeds 100 million monthly active users. Custom licenses like this require mandatory compliance reviews from corporate legal departments, which slows down the entire deployment pipeline. For risk-averse teams trying to prototype rapidly, Gemma 4 removes the legal friction entirely, whereas Qwen requires deliberate compliance planning from day one. Pacing speeds up slightly. Once you clear legal, you hit the physical engineering constraints of deploying these models on available hardware. Gemma 4 uses a mixture of experts architecture. This means it only activates a small fraction of its total parameters for any given token it processes. Because of this efficiency, a 26 billion parameter model can comfortably fit onto consumer GPUs or run entirely on a single 80 gigabyte H100. That translates to extremely high tokens per second output, a mandatory requirement if you are running high-volume, real-time agent loops. Qwen 3.6 Plus offers an alternative approach through its hybrid reasoning thinking mode. This timeline chart compares standard inference against Qwen's thinking mode. Instead of executing instantly, the model uses an extended chain of thought to map out multi-step sequences, drastically increases latency, and can easily become a bottleneck in your pipeline. MLOps engineers must sacrifice the instantaneous speed of Gemma if their specific workflow requires the deliberate, pre-planning accuracy of Qwen. Moving from hardware to the architectural design of the agent pipeline, we have to look at how these models interact with external tools and memory. Gemma 4 natively includes function calling capabilities out of the box. It has been explicitly trained on function calling data to consistently produce well-formed, structured JSON outputs. This mechanical precision is vital for reducing error handling overhead when you are building deep, sequential tool calling pipelines, where a single malformed call breaks the chain. However, Gemma has a clear architectural limitation. Its maximum context window caps out at 256,000 tokens. If you need to process information beyond that limit, engineers have to build complex chunking mechanisms or set up retrieval-augmented generation. Contrast this with Qwen 3.6 Plus, which features a massive 1 million token context window. This network diagram illustrates a supervisor agent setup. With 1 million tokens, that central node can simultaneously ingest and track raw data streams from dozens of subagent nodes without having to summarize any of the intermediate steps. But there is an operational cost. Feeding 1 million tokens into a prompt exponentially drives up inference compute costs at those extreme edges. Pipeline architects must choose between the flawless, narrow tool execution of Gemma or paying the compute premium to get the massive contextual awareness of Qwen. This flowchart synthesizes these trade-offs into a concrete decision matrix, starting with whether your context requirement exceeds 128,000 tokens, and branching down to your priorities around licensing and latency. You should treat Gemma 4 as your default starting architecture because it offers the path of least resistance. If you fit the rapid executor profile, building customer-facing automation, sequential APIs, or operating inside strict corporate procurement, this is your model. Only escalate to the Deep Analyst profile of Qwen 3.6+ when workflows explicitly fail due to context limits. That escalation becomes necessary if you have to process entire code repositories in a single pass, or if your tasks require deep pre-planning via thinking mode. Successfully deploying open-weight AI requires abandoning the search for a universal winner. You simply have to precisely match a model's operational friction against your pipeline's actual need for cognitive depth.